Hi everyone. Um, so today I participated in this Division 3 Codeforces round, and for the first time in a while, I'm, actually streaming again. So it's pretty exciting for me. Um, let's see if anyone's in the chat yet. Can people hear me okay, by the way? I'm on a bit of a new setup, so just want to make sure my audio and video are good. Okay, great. So, yeah, it's nice to be back. Definitely been a while. But I did today's round, and I thought it was pretty fun. So I thought, why not stream afterwards? So overall, I think the round today was pretty interesting. So it looks like I got 18th. And I definitely took a long time on G. Like, G took me quite a while compared to the other problems, so hopefully I'll be able to explain it pretty clearly. So I guess let's dive into problem A. Which problems did you guys in the stream do, by the way? Feel free to let me know like which problems you did, which problems you thought were the most interesting, anything like that. Definitely curious to hear that. Up to E, nice. Okay. TLE on E. Yeah, E was pretty tricky. I think there's a pretty clean solution that I'll go over, but it was definitely not a super easy problem. Okay, great. So let's just get started. Cool. So problem A, shortest path with obstacle. This is actually pretty complex for problem A, I thought. Definitely a bit tricky to code and a bit tricky to think about, but they have some nice diagrams here that we can actually look at. So basically what you want to do is you want to get from point A to point B on this grid, and you have to avoid point F. So to start with, let's pretend that point F doesn't exist. So then to get from, over to in the corner, to get from point A to point B, basically every step you either need to go sideways or you need to go vertically. And this is actually a pretty common concept. This is called Manhattan distance. So what we're basically doing here, if you notice, the answer will be the absolute value of ax minus bx plus the absolute value of ay minus by. So here ax minus bx is the horizontal distance between a and b, and ay minus by is the vertical distance between a and b. So that's going to basically be like the answer, but now we have this tricky case of what if you have f involved. So first, note that if you have a and b and they're not in the same row or the same column, then you can actually do a path like this or a path like this, where you do all the rights. Oh, my stream isn't on Codeforces. Thank you for the heads up. Let me add it back there. I guess it got automatically removed. Or not removed, but it got marked as complete. Cool. Is it back on the sidebar now? Awesome. So yeah, so as I was saying, you have these two paths that actually share no cells in common. So it's impossible for f to be on both of them, which means that as long as a and b are diagonal from each other, not perfectly vertical or perfectly horizontal, f doesn't even matter at all. So now we just have to consider the case where A, B, and F are all in the same row or the same column. So if F is not between A and B, it also doesn't matter, right? Because you would just go like this. So now let's assume that F is between A and B. So you have something like this. So you still have to horizontally go from A to B, and then you have to do one vertical and one vertical again to avoid F. So basically what we're going to do here is, so here's the code that's based on this this solution. So basically what we're going to do here is we're going to add up the x difference and the y difference, and then if this is like a bit complicated because I just wrote it all in one line, but basically this is saying, so we're having I go from 0 to 1, where 0 is the x coordinate and 1 is the y coordinate. So what that implies is this will add the x coordinates in the first iteration and the y coordinates in the second iteration, and the reason that I chose to code this way is that way I don't have to copy paste everything for the x's and y's separately. So then what we want to do is, let's just assume I is 0. So this is saying if they have the same x coordinate, A, B, and F all have the same x coordinate, and then this is a way to check whether F is actually between A and B, instead of whether F is like on one side of A relative to B. Basically what I do is I check whether the sign of B minus F and F minus A are the same, meaning that you have like B, F, A. All right. So if that's the case, then we're going to add 2 to the answer so that we can go around. I just did less than or equal to some point, less than or equal to. Yeah, that makes sense. Cool. So, all right, so that wraps it up for A. Let's get to B. Oh, someone mentioned I tried BFS. That's an interesting idea. So the problem with BFS is that you would end up getting time limit exceeded on this problem because you could go to up to 1 million cells per test case. So BFS wouldn't work. Can you try to explain easy problems faster? Yeah, sure. I'll try to breeze through the next few, and then I think things start to get really interesting around D or E. But basically, at any level, there's going to be some problem that people find hard, so I don't want to leave people in the dust too much. Cool. All right, and then, oh, thanks for the follow. Oh yeah, that actually reminds me. I also have a YouTube and a Discord, so feel free to join those. Someone said I didn't reply to their message on Discord. Sorry, maybe I'll reply after the stream. So, all right, let's do B. So let's see. Okay, so this is kind of a complicated problem statement because they had to write everything out really formally. But basically what they're saying is you start with an empty string, and then you write an A, and then you write a B either left or right of that. So let's say we write it to the right. Then you write a C, so like you could write the C here, then maybe like D, E, F, G, H, and then this gives you a valid string. So the cool thing that we want to note here is that the largest element will always be at the beginning or the end. And then once you remove it, you'll have the new largest element be one less, and it'll still be at the beginning or the end. And you can just continue doing that until you get back to an empty string. So this is a way to figure out whether something is alphabetical pretty quickly. The trick here, which is actually common in a lot of these problems of determine whether it's possible to construct something, is to try following all the steps back in reverse. So let's look at the code. So the code here is pretty simple. We figure out what the outside element should be, which is the largest element. And then here I used a deck. It's actually not necessary to use a deck here, but it makes the runtime a little faster. In this case, it actually works either way. But then what we do is, like, once we found the largest element, right, which in this example that I wrote out would be h, then oh, if you're having a lot of buffering watching, maybe you can click the gear while watching and lower your quality, if that's possible. Also, the video will be on YouTube later, so you can always check it out there if you miss something. So basically what we're doing here is we're picking the largest element, which is h, and then if there's nothing left, then of course we return false. And we do that immediately because otherwise checking the front and the back would cause like some kind of error for accessing memory that's not there. And then we check to see if it's at the front or if it's at the back, and then we remove it. And if we didn't find it at all, we return false. And then at the end, we just make sure that there's nothing left. And that's basically it. Cool. Actually, when I first submitted this, I just used the original string and deleted the front element. The reason this is a little bit better with a deck, which is why I rewrote it, is because you can delete the front element in O of 1 time, but with a string it takes O of the length of the string. But the constraints are actually small enough that it didn't matter, because they said it's only up to length 26. Okay, great. So now let's do C. Okay, so C was a really long problem statement. And I think somebody in chat was asking about C, so if you're still here, now we're looking at it. So basically what we have is two people. Okay, so you have a file, and it turns out the contents of the file don't matter at all. All that matters is the length of the file. So let's work through an example. So in the example, the length of the file is 3, and the first person's operations are 2, 0, and the second person's are 0, 5. So basically what we're doing here is the types of operations you can do are, if the operation is 0, then we're going to do k++. So we're going to add one more line to the file and increase the number of lines in the file. And if the operation is not 0, then what we're going to do is, let's just say that the operation is x. Then we want to make sure that x is, oops, wrote that backward. We're going to want to make sure that x is less than or equal to k. So if we read the problem statement again, it's basically saying you can add a new line to the end of the file, which you can do anytime, and that increases the number of lines of the file, which is k, by 1. And if you modify a line, the line must be, it says it somewhere here. Yes, there should be no changes to lines that do not yet exist. So that means that if you're modifying line 5, for example, we need line 5 to already exist. So we need there to be at least 5 lines. And we know the order that each of the people did it. It's just a matter of how they interleave their choices. So it turns out that what you can do is you can just, at every step, just check if either one of them can move. And if they can make a move, it's always okay to make that move immediately. You never make things more difficult later. Because if you modify a line, it doesn't actually change anything. It doesn't affect future operations. And if you add a line, then that's always a good thing. You might as well add the lines as soon as possible. So basically what this boils down to is just try to make operations over and over. And if you can't, and you get stuck, then you return false. Otherwise, you're done. So here's how I implemented that. Again, instead of having two separate arrays for the first person and the second person, I just used an array of arrays so that there's less code repetition. I definitely recommend this because it makes it easier to think about what you're doing and reduces the chance of typos. But basically, yeah, I reverse the arrays so that I can use them as a queue by popping stuff off the back. It's not really necessary. You can also use a queue, or you can just keep track of a pointer that goes through the array. But basically what we do here is, for both people, we have them try to make a move. If their move is less than or equal to the current number of lines, then it's a legal move. And then we'll add it to the answer, and we'll pop that off of their queue of moves. And if their move was adding a line, we'll add 1 to the current number of lines. And if both people tried, but neither one actually did anything, then this is what we're checking here. We immediately return -1. Otherwise, when we're done, we just print the answer. And this actually, if you run this on these samples, it won't match the output. The reason for that is because there are many possible sequences that work, and it just prints one valid sequence. Cool. All right, let's move on to D. Let's see my code. I implemented it easily. Okay, cool. Yeah, so people are talking about D. That's the bitwise arithmetic problem. I guess bitwise operations problem. So D definitely seems kind of complicated, but there's a relatively simple insight that I think makes the problem not too difficult. So first, we need to understand the definition of what it means for these sequences to be growing. And what that is well, they already defined it, right? Basically, they're saying that if you ever have a 1-bit in like one element of the sequence, the next element should also have that bit set to 1. Yeah, I'm back to this streaming after a long hiatus. I'm not sure if I'll stream super regularly starting now, but I thought at least today I'd try doing a stream. So they said that AI and AI plus 1, wow, it's kind of messy, equals AI. So if you think about this, what this also means is that AI or AI plus 1 equals AI plus 1. And the reason for this is because this first statement means that if you have any 1 bits in AI plus 1, they're also 1 in AI. Wait, did I actually say that right? No, I said that backward. So what this means is if you have any 1 bits in AI, well, let's just write down an example. Let's say AI is 1 0 1 0, and then AI plus 1 could be 1 1 1 0. So as they said, if you AND them, you just get 1 0 1 0. But if you OR them, you actually get the second element, which is AI plus 1 here. And they want us to find a lexicographically minimal sequence such that we can XOR them with all the values of our sequence to make it a valid growing sequence. So this effectively means that we want to make, like, in some sense, the least changes possible, but not really. We want to make the changes in the lexicographically minimal way. So this means that if we have a choice between changing, like, the first element and changing all the rest of the elements, we'd rather change all the rest of the elements. Because if you have something like this, actually, let me undo that. I won't use ones because it's confusing with the bits. If you have something like this, that's actually still less than something like this. So we care about minimizing the thing that we can do is we can try to minimize the first element of y, and then, given that minimal possible value, minimize the next value of y, and so on. So the way that we're going to do that... Oh yeah, are people trying to see my submissions? Yeah, there's actually a cool way to make a link to that. Let me see if I can... It's kind of weird. Anyway. Yeah, that method also works. Oh yeah, also after I finished the yeah, I forgot that my profile had my email. It's probably been leaked multiple times by now though. So okay, so let's actually look at the code. I think that makes this a bit clearer. It's actually super simple, as you can see. So basically what we want to do is okay, so the first element, we can always make it 0 because we can leave the first element untouched and still make all the other elements something that's growing from it. So then what we want to do is, as we said before, we need this quantity, AI plus 1 or AI, to be equal to AI plus 1. So this XORs that with AI plus 1. And that basically tells us what bits we need to change. And then as we've done that, we kind of propagate those bits up into AI plus 1. So that we can then, continue the sequence forward. So that's basically it for that solution. Let me know if that was not super clear and I can run through an example, or if it was clear and I should just move on to E. While people are answering that question, MagMikeC says, would it be possible to live stream a contest? So I'm not allowed to live stream a contest while the contest is going on, because, then people could copy my solutions. But I do have some I have some screencasts where I recorded my screen while doing a contest, up on my YouTube. And that's true. I can also virtual a contest on stream, and I have a couple of those on my YouTube as well. I didn't record today's contest, but maybe I should have, because I did it fairly quickly. So it might have been fun to watch. But yeah, you can check out my YouTube and look for, I guess, screencast or virtual, and you can see me solving some stuff in real time. You can also check out some other people's screencasts, and they're even faster. Like, I think Neil uploads a lot of screencasts and is really fast, and Geothermal is really, really fast, but I think doesn't upload screencasts. I'd definitely like to see geothermal coding sometime, but... Alright, so let's walk through an example. So let's go through the example. Let's go through the second to last example. So the numbers are 1, 2, 3, 4. So in binary, that's like 1, 1, 0, 1, 1, 1, 1, 0, and 1, 0, 1. So what we want to do is we need 1, 0 to be changed to something that contains all the bits of 1. So if you combine these, you get 1, 1. And then we want to replace this with 1, 1. And then if you combine these, oh, and then the stuff that we changed, we need to add to our answer. So we're going to add 0, 1 to our answer. Then when you combine these, you get 1, 1, so we don't need to change anything. Then when you combine these, you get 1, 1, 1. So we need to add 0, 1, 1 to our answer. And then this gets replaced with 1, 1, 1. And then when you combine these, you get 1, 1, 1. So we need to replace this with 1, 1, 1, and we need to add 0, 1, 0 to our answer. Okay, so Geothermal apparently does have a YouTube channel. That's awesome. I will check that out later then. Cool. So this is kind of what we're doing, right? We're making sure that the current element is contains all the bits from the previous elements and seeing what the minimal changes we need to do are. So then this gets 0, 1, 0, 3, 2. And let's actually check the answer. Yeah, so the answer should have been 0, 1, 0, 3, 2. So I didn't make any mistakes going through here. Donut Tube says, I did this problem by guessing. Yeah, I mean, it's a pretty simple solution. So I think that there are definitely some steps here that so I proved them to myself, but you could definitely just hope that they were true and then proceed forward and then submit it. In general, ideally you prove all your answers or all your solutions, but in practice, knowing when to make a educated guess and take a risk is definitely a valuable skill to maximize your score while doing these contests. When you're practicing, of course, I definitely recommend that you go back later and try to understand the proof and figure out all the details in depth so you can learn as much as you can from the problem. But while you're doing a contest, sometimes, if something seems right, just submit it. If it gets AC, just move on. And then, yeah, you don't want to get hacked. So another trick during contests, sometimes when I'm kind of stuck on a contest and I don't think I'll solve the next problem, I will look at the status tab and see if there are any hacks during the contest. And if I see a bunch of people are hacking B, then I'll go back and I'll double check my problem B to make sure that I'm confident in it. But if nobody's hacking other people during the contest, then I feel pretty confident nobody will hack me. And that pre-tests are pretty strong. Okay, Robel says, I have a question. If we want it to be lexicographically ordered, that if you have different length binary numbers, don't you not want to preserve the later digits? So they're saying that the sequence of these numbers, 0, 1, 0, 3, 2, should be the lexicographically minimal sequence. We're not ordering the individual numbers lexicographically. Hopefully that makes sense. I think you just misread slightly, or maybe I misunderstood your question. Cool. So, do I participate in Code Chef? Not really. I've done, I think, 2 long contests, and they were pretty fun, but I'd rather do short contests. I think it's nice to just set aside 2 hours and do a bunch of problems. Long contests kind of feel like homework. Okay, air conditioners. I think this problem was actually easier. Well, I mean, let's see my submission time actually. Yeah, so I did this problem faster than I did C or D. Not by much, but a little bit faster. But it was a problem E, so it was definitely a bit tricky, but I think I just saw the idea quickly for whatever reason. So basically, let's see. I guess they have an example here. All right, let's work through this example that they gave us. Okay, so here we have 14, and here we have 16. So someone said, why is div 3 harder than div 2? It's not. Maybe you just did better on a div 2 and got unlucky today or something. Maybe the first problem might be like around the same difficulty, but like the last problem on div 2 is really hard, whereas the last problem on div 3 is only like medium hard. Definitely still challenging though, so I think div 3s are better not because the first problem is easier or the last problem is easier necessarily, but because they have more easy problems, whereas I feel like div 2s ramp up really quickly, so if you're like a total beginner, and you're doing a div 2, you might just like solve A without too much trouble, but then not do anything the whole rest of the contest, whereas div 3s have like a gentler difficulty curve. Anyway, let's go over this problem. So basically what it's saying is that you have some air conditioners and they cool the air around them, and they have a diminishing effect as they get further. So let's look at the effect of this air conditioner. Here's what it will do. It will cool all the air to the air conditioner temperature. Actually, plus the difference in distance. So the first air conditioner, that's 14, will cool the air around it to 15, and then 16, 17, and 18. And the second air conditioner will cool the air around it in a similar fashion, so I'll write out the answers. And then for each thing, you take the minimum of the air conditioners that affect it. So you can see this would be the answer for this test case. Could E be solved with segment trees? Yeah, I think you could probably do something complicated with like a segment tree and some kind of like maybe a lazy segment tree that like adds like arithmetic sequences to the, but I'm not sure. I think it would be really complicated. So there's definitely a simpler solution. So let's imagine that each air conditioner, so there's actually a couple ways to think about this, but let's imagine like each air conditioner like cools the air around it and then spreads outward like this. So what it's doing is like, you know, as you can see from this example with the 14, let me highlight it. So this 14 then goes to the two 15s and the 16, 17, 18. So it goes in both directions. So for now, let's pretend that air conditioners only affect air to their right. So then you would have 14, 15, 16, 17, 18, and then this one would be 16, 17. And at each point, you want to take the minimum. And so if we've already processed like everything to the left of this, we don't actually care. We only care about the air conditioner that's the smallest number now, because we're just going to be adding 1 to all of them. So we only have to keep track of one thing. So we can basically implement this by sweeping from left to right and keeping track of the current temperature and then adding 1. And then if we reach a new air conditioner, reduce to that temperature, if it's lower, of course. So let's check out the code. Let's see. Okay, hopefully this, yeah, okay, cool. The code is on screen. So first what I did is they kind of gave you the air conditioners as a set of points, but instead I wanted to put one air conditioner at every point, and all the air conditioners are less than 1 billion temperature. So we can initialize each empty cell with an air conditioner with 2 billion temperature. because that's going to be so much bigger than the other ones that it won't affect anything. So that's basically what we're doing here. We're just filling it out so that every cell has an air conditioner. And then what we're doing is, let's just look at only this inner loop. So what we're doing is we're just going from left to right, and here V is going to be the current temperature. So we're going to add 1 to V. And then if we have a cooler air conditioner at the current cell, we're going to reduce our temperature to that. And then our answer is just going to be this current temperature. So this would be the solution if all the air conditioners only affected stuff to the right. So then we simply reverse both arrays and do it again, and then all the air conditioners will affect all the stuff to their left too. And that's basically it. And you can see this trick where I reverse both arrays. That way I don't have to write all this stuff twice or reverse my loops or deal with any tricky off by 1 errors or stuff like that might pop up. So yeah, you don't need a segment tree, you just need a simple loop. Does that problem make sense? Does anyone have any quick questions before I move on to F? Cool. Missing Days says not like this. Cool. All right, so let's move on to problem F. Do you usually set infinity to something much larger than possible? So in this case, I guess a safe value to set it to would be 3 times 10 to the 5th plus 10 to the 9th. But I just set it to 2 times 10 to the 9th, and that worked fine. If you set it to basically there's a lot of different ways to set infinity. You can set it to the largest value possible that won't overflow, right? You have to worry sometimes if you set infinity too high, it'll overflow, especially if you're adding 2 things together. Here, we're not really doing that. We're just adding 1 at a time, so we don't have to worry about overflow. But maybe it would have been better here to set it to 1e9 plus 3e9. I actually didn't think about this too hard, but I guess if I did 2e9 plus 3e5, would that overflow? No, it wouldn't. But yeah, you basically have to be careful to avoid overflow when you're setting infinity, but also make sure that it's big enough. It always sucks when you set infinity something too small and you just get wrong answer because of that, because it's super avoidable. Cool. All right. Max distance. So the max distance is actually 3e5 if you read it carefully, not 2e5. But basically, yeah, what you're saying is the right idea, but just make sure you plug in the right numbers. Yeah, that's exactly right. And often people add a bit of a buffer to their infinity just because it's better to have it be a little bit too high than a little bit too low. Beans1276 says this contest was easy. That's awesome. Great work. Did you solve all the problems or most of them? All right. Let's move on to F. Definitely curious if there's a cleaner solution to F than mine as well. Well, I think mine is pretty simple, but it used a bit of heavy machinery. It used a range query data structure, and then it also used a binary search. So it would be cool to see if there's something a little bit simpler. Okay, so F actually reminded me a lot of E. Where what we kind of do is let's go through an example actually. So if we have 16, 24, 10, 5, then what we do is basically each element will affect the element to its left. So 24 will affect 16, and you'll just get 16. 10 will affect 24, and you'll get... Actually, sorry, you won't get 16. You'll get 8. 10 will affect 24 and reduce it to 2. 5 will get this down to 10, and then 16 will reduce 5 all the way down to 1. And then the same thing will kind of happen again, so then everything will affect stuff 2 to its left, and 3 to its left, and so on. So at some point, every element is going to become GCD'd with every other element, and at that point, we're just going to get the GCD of the whole array, and then at that point, all the values will become equal. So the tricky part about this is it takes O of n time to perform one step, and there could be up to n steps. So my first thought actually was maybe this converges really quickly and we can just simulate it and it'll be fine, but it won't, because if you have something like 2, 2, 2, 2, 2, 2, 1, then it'll actually take the full n steps for the 1 to get all the way over to the beginning. So then that would be O of n squared if you just simulated it naively. So instead what we're going to do is we're going to binary search on the number of steps. So let's check out the code. So here what we do is we say if we've done steps, number of steps, are we going to be done or not? So as I mentioned, after you do like 3 steps, for example, each element will take itself and 3 elements after it, and it'll be the GCD of all of those elements. So this is pretty simple. What we do is each element becomes the GCD of the next steps plus 1 elements. And then what we do is we check to make sure that there's only one unique value, and if there is, then we're done. If there are multiple different values, then we're not done. And then we binary search. And we know that it'll take at most n steps, and it could take as little as 0 steps because the array could already be constant. Now the tricky part of this is how do we actually do this step efficiently? And I used a data structure called a sparse table, which allows you to perform range queries in O of 1 after n log n construction. You could also use a segment tree, or there are probably other things you could use, but those are the 2 main ones that I think work well for GCD. And I actually used this little trick where I made the sparse table twice the length of the array and just put a second copy of the array. That way it accounts for the wrapping around pretty cleanly. Like if you have 5 elements starting from an element that doesn't have 5 elements after it, that way it'll automatically take the correct number of elements from the beginning of the second copy of the array. But yeah, another pretty simple implementation, like, you know, just a handful of lines as long as you have range query data structure and a binary search, you know, pre-written. So I'm definitely a big fan of having a lot of pre-written code. I feel like it really allows you to separate the implementation details for standard algorithms. Like sparse table is a textbook algorithm, binary search is a textbook algorithm, and it allows you to just take the interesting logic from our current problem and only write about that stuff. So you end up getting these like really short, clean looking solutions. Okay, so now for G, where I didn't really have a clean looking solution. It's pretty organized, but the problem was pretty complex. Someone mentioned a clean solution without sparse table and without segment tree. So I thought about going through all the primes, but I worried that there would be too many because there are like there are like 70,000 primes, or 700, yeah, I think 70,000 primes less than a million. And I think that times n would be too much. So yeah, another way to think about this is that for every prime, you have like the minimum element in terms of how many copies of that prime go into it, and then that propagates over. But I would have thought that would be O of n times the total number of primes that appear, which could be like too much. So yeah, I'm curious whether that's correct. Maybe there's some detail I'm missing, and I'm curious whether it's you know, incorrect but passes the tests. Not many primes appear a lot. I see. So for every prime, you don't iterate over the whole array, but you iterate over the indices at which it appears. If that's the case, then I think that makes sense. Anyways, all right, let's go over G. Definitely a complex problem. So there might be like some trick to do G in kind of one step, but I just kind of broke it down into a few different cases, each of which is a pretty simple problem to solve, and solved each of those kind of sub-problems. So we basically want to figure out these 4 different cases. If there are no paths from 1 to v, if there's only one path from 1 to v, if there are multiple paths but not infinite, or if they're infinite. So let's do what I think the easiest case is first. If there are case 0, if there are no paths. So for this, we can just do BFS from 1. And after we do a BFS from 1, we just, you know, identify all the unreachable nodes, and there are no paths. Then let's try -1. This is a bit trickier. So luckily they kind of gave a bit of an explanation. Oh, Purple Crayon has joined. Hey. So they gave a bit of a explanation. Oh, hey, second thread. Is your stream already over? Okay, yeah. So as I was saying, they already gave you a bit of an explanation here, which is pretty nice. In their sample, they said like you can add the loop into a path many times, etc. So basically for -1, it'll look something like this. You have the starting node, and then you have some other stuff, and then you have some node here, and then you have some other stuff, and then you have v. And then the key is somehow this node needs to be able to return to itself. Oh yeah, I got a couple of hydrates. Forgot about those. So this node needs to return to itself, and there are 2 ways that you can do that. Either via a cycle or via a self loop. So the way that I did this is I used some pre-written code that finds strongly connected components. So a strongly connected component is a set of vertices in the graph such that every vertex can reach every other vertex within that set. So if you have a strongly connected component with multiple nodes, it means that somehow they can all reach each other, which means that it contains a cycle. So if you can reach from 1 to any of these nodes and then to v, that means that you have this path where you can repeatedly like go across the cycle an arbitrary number of times and get an infinite number of distinct paths. And then the other thing that you could do is you could have a self loop, which is like one node that loops back to itself. Cool, so that's -1. And then for the 1 versus 2 case, the way that I did that is, let me think. I think I did it a little bit oddly. Oh, so I actually didn't mention how to actually solve the -1 case. So let me do that. So the trick that I did here is I made a list of all these special nodes, and I checked whether there was a path from 1 to the special nodes, and whether there was a path from the special nodes to V. And the way that I checked 1 to the special nodes was I checked if there was a like a backwards path from the special node back to 1. So both of these I just did with BFS, and then I used the strongly connected components code that I mentioned. And then for 1 versus 2, what I did is I topologically sorted all the components. So if you have a topological sort, and let's say this is your node 1, then basically what I did is you can do like a DP on this topological sort to count the number of paths to each node. So, and I actually just labeled them all with 0, 1, or 2. So this one's not reachable from 1 because it's before 1. This one there's 1 way to reach. This one there's 1 way to reach, 1 way to reach. And this one there are 2 ways to reach. So that basically lets you determine 1 versus 2. So that's basically the whole solution to G. It's a bit of an implementation slog, at least the way that I did it. Second thread, how do you do it with just topological sort? Well, I guess like this also depends on your specific implementation of topological sort, right? Because some implementations I think like don't work if there's a cycle, and some like detect the cycle and like return something reasonable. So yeah, I'm curious how you did that. But let's quickly go over the code. So I kept track of 2 adjacency lists, one for the graph itself and one for the reverse graph, which we only use in really one step. Yeah, I think it depends on your implementation. I think there are some. I think if you implement topological sort in the right way, it'll like ignore vertices that are part of a cycle, or it'll stop once it finds a cycle, or something like that. But actually, so the strongly connected components code that I use uses Tarjan's algorithm, and it returns the components in topologically sorted order already. So I just used that once. Okay, so let's see. Okay, cool. So I built the graph. Then I check to see what stuff should be 0. So if you have so I do a BFS from the starting node, and then if something's not reachable, I assign 0. Then I find the strongly connected components, and if you have a component that has multiple vertices, all of those vertices are part of a cycle. So I added them all to this set of vertices that I called self, which you notice I also added the self-looping vertices too. Then what I did is wait, why did I do this? Oh yeah. So for all the self-looping vertices that are, oh, I actually didn't do the reverse graph thing that I mentioned. I did that initially, but then I changed it before submitting. Or maybe I changed it after submitting to clean up the code. But basically what I did is I already found all the reachable vertices from 1. So I just made a list of the reachable vertices that were part of a cycle or self-loop and saved them in this list. And then I did a BFS, multi-source BFS, starting from all of those vertices at once. And if something was reachable from one of those, which themselves are reachable from 1, then we know that there's infinite paths, so we assign -1. And then here is where I just did the DP. I go through all the vertices in reverse topological order, in topological order, which is the reverse of the order that this specific SCC implementation returns stuff. And I just keep track of this DP where every time I visit a node, I add the number of paths to it to all of the nodes that it points to, which is a pretty standard path counting DP. And then I assign those, and if it gets over 2, I just make it go back to 2, so that 2 is my number for some but more than 1. And then I assign that to the answer, and that's basically it. So yeah, that was basically what I did for all the problems this contest. I wonder if the editorial is up. It is. Okay. Cool. Someone said I used DFS and got TLE. I'm guessing you had like some kind of infinite loop in your DFS. It's pretty easy to code DFS or maybe BFS wrong in a way that visits like the same node like many times. Especially if you just... All right, well then never mind. Maybe you just did something inefficient. All right, let's read the G tutorial. The first motivation was to write a lot of standard code, like find SCCs, do a DP over the graph of SCCs. Wow, that sounds really familiar. That's exactly what I did, except I didn't write a lot of standard code because it was already written. Oh, I see. Okay. All right, so I didn't read through all of this, but it seems like it's a pretty cool idea, which is somewhat standard. So there's this idea of like marking vertices instead of visited and unvisited. You mark them as white, gray, and black when doing DFS. I think you can probably look up like DFS, white, gray, black, coloring nodes or something to like read more about this. And I think it's commonly used for cycle finding already. So I think that you can use this for this problem as well, with probably some small modifications like they mentioned. So that's pretty cool. Maybe I'll try to understand that and go into it later. Crow asks, isn't that also the technique for bipartite? I assume you mean checking whether a graph is bipartite, and the answer is I think it's not. So in that context, the coloring is like you color the graph at the end. Like when you're done, the graph is colored. What they're talking about here, when you're done, all the reachable nodes will end up being the same color, black. They're just using the colors as a stand-in for like, you know, probably better names, which would have been like unvisited, still processing, and obsolete, or something like that. Would be like better names than white, gray, and black. But this is like standard terminology, so if you like Google it, you'll find results using that terminology. Cool. Let's see what they did for this. Wait. Oh, okay, cool. So they actually didn't do it the way that I did they? Maybe they did. I don't know. It seems like they're mentioning a couple solutions here. Cool. Anyway, I guess that's basically it for this stream. Definitely a fun contest. I feel like I don't know. I've been enjoying doing Div 3s recently just because I feel like I feel like all these problems are pretty fun. They all have pretty clean solutions and like require a good amount of thought, but the solutions themselves are clean and have like nice ideas in them. So it's definitely a fun contest. If you decide to do live solves, you should enable gambling with channel points. I don't know how to do that, but that sounds pretty cool. Maybe I'll ask on my Discord if people have thoughts about that. Can you give some tips for beginners? That's pretty general. I feel like there's a pretty common question like, what's some tips for beginners, or what's some advice for beginners? What should I do to improve? And these are like pretty generic questions, right? Like, not to put you on the spot for asking it, but like you're not the only beginner. There are like lots and lots of beginners. So the same advice kind of applies to, if you're asking for advice that applies to all beginners, like that's already been answered like many times by a lot of people. There are whole books written about it. But I guess I'll chime in with my 2 cents anyway, as long as I'm here. So the number one thing I think is to practice and learn a lot. Like, competitive programming is really hard, and improving at it takes a lot of hard work and dedication. It's not like you can't expect to pick it up and immediately be really good. So a lot of people, I think, get discouraged when they feel like they're not improving enough. And I think usually it's because they actually are improving a lot. They just expected to improve faster. But it's hard to improve. Right? Like if you started playing tennis, you wouldn't expect to be like a, high level, like a top level tennis player within like a couple months. If you played like once every 2 weeks. But I think sometimes people like approach competitive programming the same way because it's like a fun hobby. So they do it like a couple problems like every week, and then after 3 months they're like, why am I not like a, candidate master yet or something? But that would be like playing tennis for 2 months and expecting to make your high school team if you played like, an hour every Saturday. So yeah, I think just be prepared to do a lot of work and then, actually do that work. Much as, I enjoy streaming and I enjoy when people watch my stream, you're not going to improve only by watching streams as well. Right? Like you can't watch tennis every day and then expect to be like a top level tennis player. You have to actually play tennis, and like you can also play sports a lot without really improving if you're not playing them like mindfully, if you're just kind of playing to pass time. And the same thing applies to competitive programming. Like if you're just solving problems, but you're not really thinking really hard about them, or thinking about what was something I missed, or what's something that I didn't know that I could learn after doing this problem, you probably won't improve as quickly as if you are doing that, right? Like you can play tennis every single day and just smack the ball over the net, but then if you are really like mindful of your play, you might think like, oh, whenever I play people, it seems like their serves are a lot better than mine. Maybe I should practice serving specifically. Maybe I should study how they're serving differently from I am. Stuff like that. So if you're doing, Codeforces, you might notice like, I can usually solve like 1600 and below problems consistently, but I end up getting wrong answer a lot and have trouble debugging. So then maybe you can try studying ways to debug better. Or you might notice like, whenever there's a graphs problem, I just don't know how to do like BFS properly. So then you should study BFS specifically. What would you say to an expert who wishes to be CM? I guess the same thing that I would say to a beginner who wishes to be CM, which is like the advice I already gave, and good luck. Do you play chess? I play chess. I don't play it that much, but I have played. I'm like an average player on like Lee chess. LeBron says, any contiguous segments of length k plus 1 will have the final GCD. I don't think that's right, because if that were true, after like 2 steps, like every segment of length 3 would have the final GCD, and then a bunch of overlapping segments would mean that the whole thing is done. So I think that what you're saying is on the right track, but the way you phrased it isn't quite right, LeBron. Where can I view the solution for problem D? So you can check out my submissions, or you can watch this video. It'll be up on YouTube later, and you can also, I think, look at my broadcast here. How do you understand the questions? Half the time I have trouble figuring out what the question is asking. Yeah, I think a lot of these questions especially had long statements. Like I said, oh, I thought they were all pretty elegant, but a lot of the statements were kind of long and convoluted. But I think I kind of glossed over that and focused more on the solutions in the code when I said this is a pretty like elegant, like short solutions contest. Just because I have a lot of experience reading the problems. But I think, like, just read the problem and then maybe try to work through the examples on paper. Keeping track of stuff in your head can be pretty difficult if it's something complicated like this. And unfortunately, the statements are only available in 2 languages, I think, English and Russian. So if you speak one of them natively, it's definitely... Actually, I'm not sure how big an advantage it is. I don't really speak any languages other than English, so I can't really speak to this, but I can imagine that this might just be kind of a little unfair advantage. If you tend to give up and read the editorial to understand the question, then I think the question is probably too difficult for... Well, that's not true, but I don't think that that's a good approach. Especially because it'll kind of lead to you understanding the problem backward by like first understanding its solution and then understanding the problem. Whereas like, I think you should focus more on developing your skills at understanding the problem itself, because then you'll learn to like solve the problem like forward, if that makes sense. Like, this is another thing about competitive programming. Like a lot of solutions can be pretty simple, but hard to come up with or hard to prove. So I think it's pretty common also for people to read the editorial and then think like, oh, that was pretty easy, and kind of move on, but not think about like, oh, that was easy to understand, but like clearly it was hard to come up with because I didn't come up with it. What could I have done to come up with it? So I think that's kind of worth keeping in mind. And I think if you're solving problems that are so complicated that you need to read the editorial, then I think that's sometimes useful, but I think it's probably better to just solve problems that are a little easier and work on understanding them more thoroughly, and then afterwards graduate to more difficult problems. This is kind of where I differ in advice from a lot of other fairly high-level competitors, where a lot of people say, oh, practice above your level, practice harder problems. If your rating is 1500, you should be practicing 1900 problems. And I think that usually that's not the case. I think usually people should like... I think you can benefit a lot from solving easier problems or like medium difficulty problems and kind of squeeze as much benefit as you can out of them. Like, after you code them up, try going back and rereading your code and seeing if you can simplify it. Think about places where you might have had pitfalls. Just work on coding faster, things like that. Donut Tube says, I want your help about a website I messaged you on Discord. Yeah, I might reply. I mean, honestly, a lot of people who like it's probably not great to DM a lot of people for help, because their time is valuable too. But yeah. Someone said, should I continue competitive programming or something else? I don't know, I would continue it if you like it, or if you have a specific reason that you want to do it, and then stop if you don't like it. To me, I feel like it's kind of the same as asking, like, should I continue to play tennis or should I continue to play chess? Just if it's fun, or if you're gonna like somehow get some concrete benefit out of it, like if you're gonna get like a tennis scholarship, then keep doing it. If you don't think it's fun, then you should find another hobby that you do think is fun. But that's kind of just more general, not really specific to competitive programming. But I guess I think of competitive programming as the same as any other hobby. So if you don't enjoy it, then don't do it. Anyone got D wrong? You're not using. Yeah, you always got to watch out for order of operations. All right, cool. Thanks everyone for tuning in. Can you share your shortest path template? Oh yeah. Let me see if this link works. Cool. So I have the repo is called algolib on my GitHub. It's copied from this other person's GitHub with a few changes, and I think my breadth first search template is on there. Yeah, I mean, you can also write your own. If you're not familiar with like a standard algorithm, I suggest you like learn how it works in detail and maybe try to write it up yourself. But then after that, I think it's completely okay to copy paste it over and over. Like here's mine. It's like a nice clean implementation that I don't have to write every time. And that way I can focus on the like fun, interesting part of problem solving. Just the same way that like, set and map and sort are built into C++. So why would I implement them from scratch? But yeah, thanks everyone for joining. Follow if you can. Check out my YouTube. And feel free to join my Discord to chat with other people or stay up to date on when I'll do my next stream. Though I haven't been streaming too frequently lately, but people still chat about competitive programming on the Discord. It's like a kind of fun social thing. But yeah, thanks everyone for joining, and see you guys next time.